Okay, so on this example, it says a plane flying horizontally at an altitude of 2.4 miles and a speed of 583 miles per hour passes directly over a radar station. Find the rate at which the distance from the plane to the station is increasing when the distance between the plane and the station is 6.5 miles. Okay, this one's nice. They give us a nice little picture. They give us all this helpful setup information. So basically, well, let's just go with it. So here's the plane. It's up here. It's flying. It's right here. It's right there, just cruising along. Okay, here's the radar station. Station. So that plane flies, it's been coming from here. It flies directly overhead and keeps on going. And this Z right here, this is the distance, from the radar station to the plane. Okay. It says an altitude, it's flying horizontally, so it's flying perfectly flat at an altitude of 2.4. So that means this is 2.4 just always. That's not changing. That's the altitude. That's the height. And then got scribbly. This is 2. Still getting scribbly. 2.4 right there, right? That's the altitude. That's how high up the plane is. It's flying flat horizontally, so it's not getting higher or lower. So that 2.4 will just stay fixed. Okay. And there we go. So step number one. What do we always do first? Step number one is we find the rate letters. So what are the rate letters? Well, let's go see what rates they speak of. Planes flying horizontally, altitude, that's not a rate, that's not changing. At a speed, 583, there we go, speed of the plane. So that's dx dt, isn't it? That's how fast x is changing, which is the distance horizontally from the radar station to the plane. So they're telling us right there, dx dt. Is x getting bigger or smaller? It's getting bigger, huh? By, whatever they said, 583 miles per hour, the rate at which x changes with respect to time, right? That's increasing. It's pauses because it's increasing. The distance of x, how far x is from the radar station horizontally, is increasing. It's flying sideways 583 miles per hour. Okay, what other rates? Find the rate at which the distance from the plane to the station is increasing. This distance. They want us to find dz dt. And I think that's it. Is that the right? Let's see. Find the rate at which distance is increasing when the distance is 6.5. This distance is 6.5, but that's not a rate. Yeah, that's it. So the only rate letters, we found them. So there are those two. Okay. Second step is you need to write an equation relating only those letters. What letters? The rate letters you just found, X and Z. So an equation relating only X and Z. So what's an equation that relates X and Z? Well, X squared plus 2.4 squared is Z squared. Now you think, how do you know you don't want to use you don't want to use Y here? Well, because Y is not one of my rate letters. See how it's so important to do this in the order I'm saying? Find the rate letters, X and Z. Those are the only rate. You think, well, Y is right here. I know, but they never talk about it. You see what I'm talking about? I just read the words and I just said, okay, where's the rate? Where's the rate? Where's the rate? There it is, speed, and that's speed of the plane. So that's dx dt. And then I kept reading. Then I find a rate, distance, that's dz dt, and they didn't mention any other rates. So those are my only rate letters. So I want my equation to just have x and z. So I don't want to use y. I want to use 2.4. And here, do I want to use 6.5? No, I want to use z. Why? Because again, I want x and z. So long story short, my equation is going to be um, x squared plus 2.4 squared is z squared. So I don't put in y because y is not one of my letters, and I don't put in 6.5 here because I need z, and z's changing. It's not always 6.5. It's changing. The distance away the plane is from the radar station is changing. So there's how you know to write the equation. And then step 3, ddt. Both sides. Take the derivative with respect to time of both sides. So let's do it. So we come in here and we go ddt, ddt. So what do we get? 2x dx dt plus 0. Derivative of a fixed number is 0. It's not changing at all. Its rate of change is 0. And this is 2z dz dt. Well, let's right away divide by 2, divide by 2, divide by 2, cancel, 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 cancel. And we just get x dx dt. This part is just 0. It's just gone. Equals z dz dt. So that's nice. And then step 4, plug in your numbers. Now you can plug in the rest of the numbers. What other numbers? Well, I know z is 6.5, so let's do that. Okay. And dx dt is 583. That's right here, dx dt. Okay, do I know x? No, how am I going to get x? Well, remember this equation? Um, yeah. So right, if you look at this little triangle, see how it's x squared plus 2.4 squared equals, and now I can put in the 6.5 squared. You see that? And I can solve for x. Because now we're free to plug in any numbers we want. So I'll just say, okay, I'll write it down here if it's helpful. X squared plus, what is it? 2.4 squared equals 6.5 squared. See how I got that? It's because of that little triangle right there, right? Do you see how I know when to use z and when to use numbers? At the very end, on step 4, it's all numbers. Go for all the numbers you want. 2.4 squared plus x squared is 6.5 squared instead of z. You can write that. Earlier, I used z because I was trying to get an equation with x and z. So follow my steps, you'll be good. So then x squared then is going to be 6.5 squared minus 2.4 squared. And then we just go root it, root it. So then x will be that square root. So I'm running out of room here. Let me move these down. Didn't realize I was going to use up all my room. So this will be, what was it, 583 equals, what was z? I already forgot. Z was 6.5. And then dz dt, I think is what we're looking for. Um, there we go. The dx dt was 583, right? Yeah, well, that's right. Right there. Okay, and then this thing. It's going to be 6.5 squared minus 2. What that is x, huh? Okay, last step. Let's solve this thing for dz dt. So just divide by 6.5 on both sides. Boom, boom. And we'll get dz dt. Let's go to decimals at the bottom square root of 6.5 minus 2.4, 6.5 minus 2.4, 6.5 minus 2.4, square root 6.5 minus 2.4 squared. 6.5 minus 2.4. What else we got? 6.5 minus 2.4 times 583 over 6.5. 583 over 6.5. 83 over 6.5. I think that's it. That's 541, 803. 541, 803. 541, 803. Is that the correct answer? Yeah. 541.8. Yep. There we go. We were able to find dz dt like that. And so there we go.